Going to solve the problem bomboane5 which was asked in Olimpiada Județeană 2024. Please read cerință. So I will directly dive into the problem. So in the first cerință we have 51 candies and 5 kids, and the third number we are not going to use. It asks how many candies each kid will get. It is possible that in the box there will remain a candy. So if we have 51 candies and we have 5 kids, each kid will get 10 candies and 1 candy will be in the box. So that's why here in the first cerință you just print n divided by x. Since n and x are integers, you will have the correct result. In the second cerință, it asks how many maximum number of kids will get candies if we distribute all candies. So no candy remains in the box, but each kid must get at least 2 candies. So in our case, let's see what we can do. So here it is 17, which means that if each kid will get 3 candies, 17 kids can get candies. So let's start it. First, it says that each kid must have at least 2 candies. So at the beginning, I'll have my candies, which is 2. And I'll create a while loop where number of candies divided by candies that each kid will get is not equal to 0, which means if it's not divisible, then I will increase the number of candies by 1. So if let's say if n is even number and it is divisible, then it will not enter this loop. And then finally I'm going to print n divided by candies. So let's check it. Yes, it takes some time to upload the code. So as you see at the beginning, I will try with 2 candies. Yeah, it's correct. I'll try with 2 candies, and if it's not divisible, I will increase the number of candies by 1. But once it's divisible, it will no longer enter the loop, and you just divide all candies to this number. So now let's go to the third cerință. In the third cerință, it asks us, so our aim is to remain minimum number of candies in the box. It can be even 0, but in such a case that at least, in this example, at least 5 kids will get candies, and each kid will get at least 8 candies, and the minimum number of candies must remain in the box. And for the solution, if only 1 candy remains in the box, 5 kids will get, each of them will get 10 candies, because in total we have 51. So our aim is to minimize this, but at the same time maximize this. So that's why I'm going to solve the third cerință. So in the third cerință, I will try to start with 0. So at the beginning, 0 candies will remain in the box, and I will try to find the solution. If I can't, then I will leave 1 candy in the box, and again I will try to find the solution. If no, I will increase the number of candies that I will remain in the box. That's why I want to create a for loop where I start from 0. So at the beginning I will try to remain 0 candies in the box, and I will just continue until the number of candies. And then let's create a variable in box. So in the box I will remain I candies. So at the beginning I will remain 0 candies in the box. If I can't find solution here, then I will increase and I will remain 1 candy in the box, and so on. and then the total number of candies that I can distribute after leaving some in the box will be number of candies minus I, so, which is actually in box. So the total number of candies that I can distribute is number of candies minus the number of candies in the box. And then remember that I must distribute to at least this many kids, and they each one get at least this many candies. But my aim is to maximize these. That's why I want to check. So let's call this one X and this one Y, which we have right here. So this total must be divisible with X and Y at the same time. But the divisors must be equal or greater than X and Y. That's why here I want to find the divisors of the total number of candies that I can distribute. So that's why I'm going to create a for loop where I start from Y, not 1. Why? Because this is the smallest divisor for the number of candies each kid can have, and this is a smaller divisor which represents the number of kids. And I will start from Y and I'll go until J multiplied by J is smaller or equal to the total number of candies that I can distribute. And here, guys, here you want to check if total number of candies is divisible by J, and at the same time the total number of candies divided by J is greater or equal to X, because it must be so. So why did I start with Y but not X? Because if J is smaller divisor, total divided by J will be bigger divisor, which I want to assign to X, which is number of kids, because I must maximize the number of kids. So in that case, I'll just print cout how many candies I have left in the box. So I'll put a space, and then I'll print total number of candies divided by J, like how many kids got the candies, and then I'll print J, number of candies each kid had. So if I find such a situation, I just print the line and I terminate all programs. So if this is the case, I will just say return 0, which means my program will end here. So let's add the solution. So we have 95 points, so we are missing a case. So let's look to the situation where number of candies is 100, where X is 7, and where Y is 11. So you see that since this is 11, so 11 multiplied by 11 is never smaller or equal to 199 or whatever, so it will never enter this loop. So here we try to maximize the number of kids, but if it's impossible, then we will do a reverse. So we will assign the smaller divisor to the number of kids, and the bigger divisors we will assign to the number of candies that each kid can have. That's why sometimes this loop will not work. That's why I'll just copy this loop and paste here. So if this never works, then it means that I couldn't maximize the number of kids. So in that case, I'll just simply start my loop with X, and then here we have to make this one Y, and here I just want to print J, and here I want to print total divided by J. So doing this, actually, now we are covering all cases and you got 100 points. Thank you for listening. Good luck, guys.